Okay, so remember when we had force times time is mass times change in velocity, okay? Well, the angular equivalent of force is torque, time is time. The angular equivalent of mass is moment of inertia, and the angular equivalent of change in linear velocity is change in angular velocity. So we've got torque times time is moment of inertia times change in angular velocity, right? So this is our torque. This is going to be meter newtons. This is time. It's going to be seconds. This is moment of inertia. Moment of inertia, that's going to be kilogram meters squared. I'll leave it for the talented and gifted students to show that meter newton seconds are the same as kilogram meters squared times angular velocity. Change in angular velocity. And that's going to be radians per second, okay? So we can do the same sorts of things. Now, obviously, we can solve this with dynamics, but let's use our new equation to do this, okay? So a merry-go-round's a 340 kilogram cylinder with a radius of 2.2 meters, right? So let's figure out that I. That I is going to be 1/2 mr squared. So it's going to be 1/2. Here, we'll separate this. 1/2 times 340 times 2.2 squared. So 0.5 times 340 times 2.2 squared, 822.8. And that's kilogram meters squared. Okay, so let's see. Torque of 94 meter newtons, so that's our torque. So let's fill it in, right? Torque is 94 meter newtons. Time is 15 seconds. I'm just filling it in. Here's our time, right? Is equal to I, which is 822 kilogram meters squared. And then our change in angular velocity is what we're trying to solve for, right? So 94 times 15 divided by the number I just got, the 822. I'm getting 1.714 radians per second. All right, now, please stop watching, but I'm intrigued, right? Is a meter newton second is a meter newton second the same as a kilogram meters squared times radian per second? Is it? Let's see. A newton is it's meters. A newton is a kilogram meter per second squared, right? So meter newton is a meter kilogram meter per second squared, and then multiplied by seconds, right? So seconds cancels, and you end up with kilogram meters squared per second, which is that. Of course it works, because it's physics.